All right, hello, my wonderful students. This is part 3 of Foldable number 4 for graphing the sine, cosine, tangent with the phase shift and k. So once again, we're going to be using our formula. Let me make sure I'm using the right color. There we are. Y is equal to a tangent of b theta plus c plus k. And as you can see, we have most of our variables already there, which is awesome. So we're going to go ahead and go to our amplitude. So our amplitude is going to be 2. I know it says -2 here, but the negative is just going to affect the direction of where the graph starts from. It's basically just like anything that you have like this, it just reflects it over the x-axis. Then we're going to do our k. It's easy to do. Our k is going to be equal to +2. Then we're going to work on our period. So remember, when you have period for tangent or cotangent, it's actually going to be pi over 2, not 2 pi over 2 like sine, cosine, secant, and cosecant. Pi over b, sorry, pi over b. It's going to be 2 pi like sine, cosine, tangent, and cosecant. Or sine, cosine, secant, and cosecant. And pi over b for tangent and cotangent. And our b here is 2. I know it's a little scribbled. Coincidentally, they're both a little scribbled out. So it's going to be equal to pi over 2, which makes it a whole lot easier to do. Now we're going to go ahead and solve for our phase shift. So this is going to be this here equal to 0. So we have 2 theta minus 2 pi equal to 0. We're going to add 2 pi to both sides plus 2 pi. Then we're going to get 2 theta is equal to 2 pi. Oh, it makes it a little easy. Divided by 2 divided by 2. We have theta is equal to pi, which is awesome. So instead of starting in the 0, we know our center point is going to be at pi, which is about right here. But it's not actually going to be at pi because we actually have a k of 2 as well. So that means if we were to do 1, 2, 1, 2, that means this is going to be here. This is our center point, which is at pi, right? So we're actually also going to do our phase shift. Or a period, sorry, from our phase shift. We're going to go ahead and divide this by 2. So we're going to get pi over 2 divided by 2 over 1, because 2 over 1 is still 2. So this lets us multiply by the reciprocal, and we get 1 over 2. So this is going to be pi over 4. So this is the distance we're going to move from our center point here, left and right, because if we move it left and right, we'll have the 2 that we originally get back to our period. So we're just going to go ahead. I know it's going to be a little skewed, but it's okay. We're going to move this over here and then over here. We can't really just put pi over 4 and negative pi over 4 here because that's not really what's going on. So what's actually going on, we have our period or our phase shift of pi. So we're going to have pi and we're going to add our pi over 4. And then we're going to do the same thing and subtract. When we add the pi over 4, we're going to move the distance over here. And when we subtract, we're going to move the distance over here. So we can't really add this yet. So we're going to have to multiply this by 4 over 4. And do that. And then we have 5 pi over 4, which is going to be the one here. 5 pi over 4. And then if we subtract it, we have pi minus pi over 4. I shouldn't have did it so high, but it's okay. And then same thing, we're going to do 4 over 4 so we can subtract, and this ends up being 3 pi over 4. So that's what's going to be here, 3 pi over 4. All right. Tangent again also has, so these are the ends. Tangent also is going to have some middle points here. And it seems like we're going to just make it, make it easier. I'm just going to go ahead and work it out. This is going to be 9 pi over 8. And the one that's in there is going to be 7 pi over 8. You guys can do the math. It's just basically add 3 pi over 4 plus pi and divide it by 2, which is going to give us our 7 pi. And same thing with this. It's going to be pi plus 5 pi over 4. And then divided by 2, we get that one right there. So we're going to go ahead and draw our asymptotes for tangent. It's a little bit squished here, and then our center point is here, right there. It's a little bit more to that way, I guess, but it's all right. And our thing was 2, our amplitude was 2, so that means it's going to touch down. Oh, and it's negative, so we got to make sure we do that. So that means it's going to come from the bottom. It's going to touch down here, and then it's going to touch down at the actual x because it's 2. From here, it's 2 up and 2 down. So we're going to go from the top to the bottom and graph our nice tangent function like that.